All right, so we have around 70 people watching this presentation, and you guys are coming from all different kinds of walks of life. You have researchers, we have undergrads, we have grad students, we have faculty, we have researchers, IT, we have librarians, most of us from Canada, but we also have people from States and Australia. So I have to stay in a very general mode, so we'll be presenting quite general ideas about research data management, but very practical too. And I will leave around 20-25 minutes for questions at the very end. And if you have anything specific or you want to focus on a specific area, please let me know. So my name is Eugene Barsky. I'm a research data librarian in UBC. I've been in UBC since 2005 or 4. My job, person who just joined, you can mute yourself. My job at UBC is to manage all things research data, and I work with VP Research and the library together to have an holistic. People who are joining us now, if you don't mind, there's a mute button, and you can mute yourself. So today, I plan to cover a few things. I want to give us a quick overview of what research data management is. I want to work with the tri-agencies approach to research data management. I would like to give you some best practices for research data management, and by best practices, I will be focusing on metadata, on the storage, on preservation, and so on. And I would like to focus for 20-25 minutes on Dataverse as one solution for research data management. Now, if you just come to watch Dataverse in action, you can come back in 20-25 minutes, or you can hang around. I also plan to use our little data guide. You can go to, we just Google UBC research data, not database, research data, and you will get to our little data. You will get to our little website, research data management. There, under Learn, you will see UBC Research Data Guide, which I will be referring to today. So if you can take a second to download it, UBC Library Data Guide. I will be referring to this little guide today for specifics like for storage, for backups, for file formats, for file naming. I will be referring to this little data guide. Again, if you just Google UBC Research Data, go to Learn, you will see the data guide. It'll take a minute for you guys to do it. Or you just, I don't know if the link is clickable on your screen, maybe it is. Maybe a couple of seconds. So today, I will be focusing on the kind of ingredients for the data cake. So there are many ways we work with data in our institutions. We work with data as a raw files, then it becomes information for us to use, then we present, and the presentation disseminated as a knowledge dissemination. But today I'm focusing on the flower and the eggs. Really, we're focusing on the very first step in acquiring data. As you know, we live in a very rich, data-rich world. Just last year, the racing in US Grand Prix collected more data than has ever been collected in the Library of Congress, and those guys collecting data since for the last 250 years. So there's tons of data floating around, and if you like sailing, you will know that a boat collects around 5 gigs of data per day, and it's all collected in real life and being analyzed to improve performance. So data is all around us. There's lots of it. Unless you are born in British Columbia, like my kids, the only data is the little APGAR test, and I don't even know if anybody has recorded it anywhere. So data is rich in some areas and poor in others. So, and I'll be talking about some of those issues. But I would like to start with us to watching a little video. It's going to be a little awkward because we come from different feeds, different setups, but I'm hoping you can watch it with me together. It's around 4 minutes, and let's see how the sound works.
Hello, my name is Dr. Judy Benign. I'm an oncologist.
Can you hear me, the video?
Hello, Dr. Judy Benign.
I read your article on B-cell.
Yes, we can.
I think that I could use the data for my work on pancreatic cancer.
I am not an oncologist.
I know, but I think I could use the data for my work on pancreatic cancer. Do you have the data?
Everything you need to know is in the article.
No. What I need is the data. Will you share your data?
I am not sure that will be possible.
But your work is in PubMed Central and was funded by NIH.
That is true.
And it was published in Science, which requires your data.
I did publish in Science.
And I have a copy of your data.
I am not sure where my data is.
But surely you saved your data.
I did. I saved it on a USB drive.
Where is the USB drive?
It is in a box. It is in a box at home. I just moved.
But can I use your data?
There are many boxes. So many boxes. I forgot to label the boxes.
Hello again. Thank you for sending me a copy of your data on a USB drive. I received the envelope yesterday.
You are welcome, but I will need that back when you are finished. That is my only copy.
I did have a question.
What is your question? You might find the answer in my article.
No. I received the data, but when I opened it up, it was in hexadecimal.
Yes, that is right.
I cannot read hexadecimal.
You asked for my data and I gave it to you. I have done what you asked.
But is there a way to read the hexadecimal?
You will need the program that created the hexadecimal file.
Yes, I will. What is the name of the program?
Cytosynth.
I do not know this program.
It was a very good program. The company that made the program went bankrupt in 2007.
Do you have a copy of the program?
I do not use this program anymore because the company that made it went bankrupt. Maybe you could buy a copy on eBay.
I have good news.
You again.
I talked to my colleague. She knew a person with a copy of the software.
Then why do you need me? Everything you need to know about the data is in the article.
I opened the data and I could not understand it.
If you have the program, you will find it is clear.
Well, I noticed that you called your data fields SAM. Is that an abbreviation?
Yes, it is an abbreviation of my co-author's name. His name is Samuel Lee. We call him Sam.
I see. And what is the content of the field called SAM1?
Ah, yes. SAM1 is the level of CXCR4 expression.
And what is the content of the field called SAM2?
That is logical if you think about it.
What is the content of the field called SAM2?
I don't remember.
What about SAM3? Is there a guide to the data anywhere?
Yes, of course. It is the article that is published in Science.
The article does not tell me what the field names mean. Is there any record of what these field names mean?
Yes. My co-author knows what the content of SAM2 is and SAM3. And SAM4.
Can I talk to your co-author?
I'm not sure.
I would very much like to talk to your co-author.
Well, he was a graduate student. He went back to China 2 years ago.
Can I have his contact information?
He is in China. His name is Sam Lee.
I think I cannot use your data.
You could check the article to see if what you need is there.
Please stop talking now.
All right. So if it was more interactive session, I would ask you what's went wrong in that situation, which is not an unusual situation in a sense, because we often get asked for a copy of our own data and we can provide it to people. We don't have data dictionaries. We have the only copy lives on the USB key. We don't have a way to describe the variables and so on. So we'll skip that part. But if you have any thoughts, type it in the text box, in the chat box, and Jana will pick them up and we'll see what you guys think. So let's see why we do data management. There are many reasons. I can actually fill many slides with that, with data management needs. But first of all, it's for you to be able to find your stuff and different kinds of your own stuff. Also, it's good for science. Reproducibility of science is really important now. You can pass your work to a different person once you understand how your data is organized. You can satisfy grant requirements, and I will be talking about granting agencies in a second. You can satisfy research ethics boards like BREP or CREPS in your institutions. And also more and more journals asking for a journal, asking for data to be open. So we'll have some examples for you as well, like PLOS and science. If you take a look at data lifecycle, let's do it quickly. Data lifecycle, as you know, most of you are researchers. You start with creating data, then you process data, then you analyze it, and sometimes preserve it, usually not. Giving access to it, and other people or yourself can reuse the data later. So our focus today is this guy. We want to focus on giving access to data. That's where we are going to be spending most of the time today. But I know some of you are actually teaching other parts, like Alex Azumov, for the call, is teaching analyzing data. The libraries have been working a lot with preserving data and processing data as well. So, but today my focus is on the access side of the data. Let's talk about regulations. So we have a couple of people from states on this call, and you will know back in 2010, late 2010, the National Science Foundation, the NSF, started to require people who receive NSF funding to be submitting data management plans together with the application. And data management plans is a two-page document where researchers outline what happens with their data as they go, what kind of format the data is, what the metadata is being used, how they keep this data confidential if it is, how it's being described, what metadata standards, and so on. Since 2010, more and more agencies and states, in fact, all the U.S. federal agencies are now requesting a data management plan. Now, data management plan does not mean you are opening your data sets. It means that you are providing a description of what you do, how you plan to work with your data. And back in 2013, the late 2013, Office of the President for Science and Technology issued a memo to federal agencies saying, DMPs, data management plans, are great, but not enough. And different agencies start thinking now how to require researchers to open their data sets as well. So in Canada, they are a little bit behind. They work very closely with the federal tri-agencies, and by tri-agencies actually didn't define it, but the three tri-agencies in Canada are CIHR for health, NSERC for natural sciences and engineering, and SSHRC for social sciences and humanities. So those tri-agencies came together with the CFI and the Genome Canada and released a statement, a joint statement on research data. That was, the draft statement was released last year. The real statement is released this June. And I'm going to analyze it a little bit for you to make it easier for you to understand what are the roles for researchers, what are the roles for funders and for institutions. But we also have a policy, tri-agency open access policy. That's the final results of your research, the articles, the papers, the books, and so on. If your research has been funded by tri-agencies, you're supposed to open that research, not the data sets, but the research output papers within 12 months. Do you see the difference, by the way, if you notice the difference between policy and statement? So right now, the data work with tri-agencies is a statement, so you don't have to do it at this moment, but you will need to do it soon as this statement becomes a policy. So expectations, I'm trying to break it a little bit for you, break it down for responsibilities. So most of you on this call are researchers. So you will be expected by trade agencies to incorporate research data management best practices in your field. Now, some fields do not have anything at all. If you work in genomics, you have actually very good practices for research data. But if you work in sociology, you actually don't have anything. So first you have to develop those best practices. You will be expected to develop a data management plan. I will be talking about it quite a lot today. And you will need to follow institutional policies and standards. I know many of our institutions, including UBC, are trying to create a comprehensive, holistic policy for data. And right now, I only know University of Alberta that has one. For funders, that are agencies themselves, they are expected to promote the importance of research data management, provide clear guidance, and provide the peer reviewers with some guidance how to assess applications. But the most important is institutions. So that's for us, like an institution like UBC is expected, or will be expected as the statement becomes policy, to provide the researchers access to repositories that can manage data. That's why we are talking about Dataverse today. Because it's a repository that allows you to curate and provide data. You also need to provide researchers with guidance, how to manage their data, and they promote the importance of research data to all our stakeholders, researchers, students, and staff. So UBC has done lots of work in all those areas, so I'm happy to share it. If you have never seen a data management plan, and my sense is some of you haven't actually seen it, it usually includes information about what kind of data you have, how you describe it, how you secure it, do you encrypt it, do you need to encrypt it, how sensitive your data is, how you store your data, do you have backups, who owns the data, intellectual property, how do you share it, do you archive it, is there any preservation strategy, so things like that. So instead of each institution going to produce their own templates for data management plans, and instead of each researcher worrying about complying to that institution needs, a bunch of us coming from portage national work have created a software package that allows people in Canada, all researchers in Canada, to log into a product and create a data management plan. So if you haven't seen the product, you just can Google DMP Assistant. It's a bilingual product coming from a Canadian Association of Research Libraries portage initiative. Let's actually quickly take a look on DMP Assistant. Oh, I will log out. I will log out. So it looks like this. It's a software package that allows all researchers in Canada to prepare data management plans to satisfy their agencies. So instead of each of us trying to invent the wheel, we have that tool for the whole country where any researchers for any institution can come in, log in with their username, password. Soon we will have CAT authentication, so you will be able to log in with your local institution. So if you come from UA or University of Toronto, you will be logging in with your local authentication. Right now it's a username password, but we expect this to be ready within a couple of months. Once you log in, you will have a template. Let's create plan. You'll have a little template. You might have a template for your own institution as well, like Waterloo, or Ottawa, or Toronto. I'll choose UBC because I've done that template myself. And once you click on the create plan, you will have a list of questions. By answering those questions, you are creating a data management plan. For instance, we're asking you, hey, how do you collect your data? What kind of formats that data is in? By answering those questions, well, in saving them, you will be able to go to export, and you will be able to create a file, data management plan, which you will attach to your application. It can be a PDF or it can be XML or different kind of formats. So we have created a solution, a bilingual solution for all researchers in Canada to be able to create data management plans on the go. And if you see a local template, like your local UBC template, for instance, you will have a local help and local guidance of how to approach specific areas. For instance, when I talk about metadata, the UBC guidance will provide local help about metadata. So what our local experts think about metadata. When we talk about encryption, for instance, we will give you a local solution for encryption and so on. When we talk about metadata standards, we'll talk about our own specific standards in UBC and provide you email addresses to work with. So what we are trying to do, we are customizing that tool for specific institutions as well. So if you come from USask or you come from University of Manitoba, hopefully your institution will have a customized guidance. Now, if it doesn't, if the institution does not have a customized guidance, you'll have a portage guidance, which is national guidance, where we created guidance for anyone in Canada to be able to create data management plans. And those are very general kind of guidance. We don't give you information about specific UBC encryption, but we give information about encryption as a whole. So if you haven't seen data management plans in action, it's a good tool to be able to create data management plans. Now, in states, they have a very similar tool as well. It's called a DMP tool. And what we are doing right now, we are amalgamating the code base for both DMP Assistant and the American DMP tool and the UK DMP Online, all those three software packages that they allow researchers to create data management plans within a year or year and a half. Will be amalgamated into one package. So, and everyone in the world will be able to reuse them and create data management plans. Okay. Now let's get to some meaty parts of what we are going to discuss today. I'm going to talk about 4 different areas, and we'll start with metadata. So if you haven't seen metadata, I don't know if you see my picture actually, not positive. If you get your sweater out and you will see on the back of your sweater, you will see something like that. That's your metadata. Metadata is data about data. Data about data that allows you to describe what this file is, where it's coming from, how you created it, when it was created, why did you create this file. So in research data management, metadata is the key. Without metadata, your data doesn't make sense. Remember that little video we watched 10, 15 minutes ago. Without data dictionary, if nobody describes what a variable SEM1 or SEM2 means, nobody will ever make sense of it. So all this stuff is gone. So metadata is the key for us to have successful research data management. We could start by something as easy as naming your files. So this is a server screenshot from some files that I've seen. Files like awesome or even awesomer. So people naming their files in a very interesting way, and it's not always helpful way. So we have a little guidance for you. It's on. If you downloaded our data guide in the very beginning, if you haven't, just Google UBC research data, and under Learn section, you will see data guide. You can download it, and page 9 has the instructions how to name your files, or you can follow that link. So we have a set of instructions how to name your files. Like for instance, how to put dates in, why we are using those dates. We are also saying, hey, don't use any special characters. If you need to, use underscores as delimiters. Try to give your names that actually make sense. Try to keep versions if you can. Now, of course, if you're using GitHub or solutions like that, you don't really have to worry about it because it does it for you. But I'm not positive how many of you guys on this call are using GitHub, since we have both programmers, but also librarians and students and faculty. So we have basic instructions how to name your files well for somebody else to try to make sense of them. Again, on Data Guide, page 9 has them as well. There are different kinds of metadata. We usually start with describing just 3, and all of them are important. Descriptive metadata is what you usually see. Things like title, author, keywords, that's what you usually, when you go to find an article on the web, you find them by those descriptive metadata. You find articles by specific person coming from a specific institution. But there's also other kinds of metadata, like administrative metadata, that allows us to see, hey, who owns that data set? How did you license that data set? We'll talk about licenses today as well. What kind of software is needed to read this data set? Also, structural metadata allows you to link between data sets, data files. For instance, it allows you to link the data dictionary with the data set and with the publication. That's a structural metadata. It allows you to connect those items to one another. There are lots of standards for metadata, actually many standards, hundreds of them. And different disciplines use different standards. If you haven't used a standard-based metadata, there's a link to Metadata Standards. If I'm coming from the Digital Creation Center in the UK, they have the great job of amalgamating them, putting them together. But if you have worked with research data so far, most probably using a simple metadata standard like Dublin Core, or if you work in ecology, you might be using Darwin Core, which is an expansion of Dublin Core. We have people in BT Biodiversity Museum here in UBC. They have done amazing work with extending Dublin Core into Darwin Core and amalgamating that with all biological elements and species and so on. If you work in the health sciences or you work in libraries, social sciences, you're familiar with DDI, which is a very familiar standard for people for the last 20 or so years. In Dataverse, we mostly use DDI to describe data sets. At the very least, and I always say to researchers that we work with, we have 30,000 data sets data files in the UBC Dataverse. And at the very least, I tell researchers, I will not take your data unless you document the variables in the README file. We need that file to understand what kind of stuff you have. If you don't describe your data, nobody will ever make sense of it, so don't give it to us. And I have information on Data Guide, page 8. So the questions, I guess, will come at the very end. So you just note them, and Jana will pick them up, and we'll address the questions in the last 20, 25 minutes. So let's go talk about data storage. I'm actually scared to ask how many of you are keeping your data in the USB keys. There was a recent article in the Other Plus or Nature. Researchers just left random USB keys lying on campus, and they wanted to see how many people will actually plug them in as they find them. And almost everyone who found a USB key lying down, free USB key, was plugged them in their own computers or laptops, and that key had a software that pinged the researchers. So that's showing that USB keys is really a cheap commodity, and people should be not using USB keys to keep their data. They're not secure at all. The basic rule for data storage, the very easy rule to remember, is the 3-to-1, which means have at least 3 copies of your data. Keep them in 2 different media. So if you use your laptop for your data, use an external hard drive, or use a CD, or use a DVD, or use a cloud. It depends on how sensitive the data is. And keep 1 backup copy offsite. So if you work at home, keep 1 copy at work. If you work at work, keep 1 copy on the cloud. 3-to-1 is an easy rule to remember. Data Guide page 11 has more information about the backup rule. So again, I'm giving you guys this kind of stuff because we have a huge variety of people on this call. We have our researchers, we have grad students, we have librarians, we have IT people. So I want to be trying to bring us to the same page. As an example, in UBC, we have a whole bunch of different storage solutions. For big data, we are using Westgrid, compute counter networks. We have a workspace for sharing data, and we have storage grids that people can release from UBC IT. But the most important part is talk to your IT people. I talk to your IT admins, they're amazing. They will know their stuff. They will know where to take your data to. Still metadata. So if many of you might be working with Excel spreadsheet to analyze your data, and if you keep your data as an Excel spreadsheet file, it actually sucks. Because in 20 years, you most probably will not be able to open your data set. Excel might not be in business anymore. Think about Lotus 123. It was a killer application just 15 years ago. We have data sets in that format that nobody can open anymore. So what we are trying to say, and we have information in Data Guide page 1112, we are trying to say, if you want your data, if you think that data is going to be important for your colleagues, for yourself in the next generation or so, 10 years even, try to keep it a non-proprietary if you can. So of course, if you have a CT scan from a specific machine, it's harder to do, but you still can convert it to DICOM. If you have Excel spreadsheet and you want to keep that Excel spreadsheet for a long time, convert it to CSV. If you have a Word document, your dissertation was written in Word document. Itself, you'll be appreciated. This is not a really software for for webinars, so you have to rely on you guys to keep quiet. If you have a Word document in a DOC format, please keep it in text or ASCII. That way, you'll be able to keep that file for a long time. Try not to compress it, like if you have a TIFF file and it's in uncompressed standard. Don't convert it to JPEG because you will lose your data. You will lose your data there. Data security by itself, it's a big issue. A whole bunch of stuff there. The most important part is how your compliance to ethics if you have sensitive data. And a good idea will be to encrypt your sensitive data sets. UBC provides free encryption services. I bet your institution provides free encryption services too. It allows you to encrypt almost everything. It allows you to encrypt your computer, your hard disk, your external hard drive. It does not encrypt your phone. So if you keep your data on the phone, you might rethink that unless you use the application like RedCap, which allows you to keep the data secure, uploaded to a secure encrypted server. Data sharing. Why share data? There are many hurdles to sharing data, but we really want, we don't want to create the same data sets over and over and over again. It's really to promote innovation and collaboration between researchers. In fact, many journals now require you, when you publish an article, to open that specific data set or sub-data set. A good example will be PLOS, Public Library of Science, really big journals. They are running one of the biggest journals in the world, PLOS One. Another good example will be joint data archiving policy in ecology. They have 82 journals that came together, and as a group, they're requiring any data sets that for any articles published in those 82 journals in ecology to be deposited in Dryad or in any other repository. So they will not take your article unless you deposit data sets. And we have good examples from in our UBC Dataverse where we took data for PLOS publications. Lots of challenges to sharing data. We understand many of those challenges. First of all, researchers not always want to share data. It's their bread and butter. They will be milking those data sets as much as they can, and they should. There are also issues with sensitive data. You have to comply to BREP. If you want to open your data after you completed your ethics application, so you have to resubmit your ethics for another consent, of course. Data needs to be de-identified, and this is by itself quite hard. And we are talking about sensitive data here. If you have data from a machine that reads temperature in your building, no issues like that will be applying. We have a checklist that we created for researchers. So it will be in our little presentation. The checklist allows people to understand what kind of data can be or cannot be shared. So but it's UBC specific. We would love to do one of those for other institutions as well one day. So it's on my presentation that's going to be shared. Also, patents, co-authors, different countries, and so on might be an issue. So we're getting to Dataverse. We are running a platform in UBC. It's a Dataverse platform, and I will be talking about different ways we can make data easily accessible and manageable in Dataverse. And why we do Dataverse? Because it allows us to license data well. It gives a nice data citation. We issue DOIs for those data sets, and DOIs are amazing. They're really lingua franca for discovery. So once you issue DOI, that digital asset will be findable in many other places like ORCID, DataSite, Google, and so on. We have version control, we have integrity checks. We are working on a preservation layer from Dataverse to Archimedica with University of Toronto's help. And we have granular access to sensitive data. So I will be showing all this stuff in a minute. If you don't like Dataverse as a repository, there's a whole bunch of others. They live on the REST3 data is a directory of repositories. If you want to see a repository in biology, you can head to the REST3 data, type biology, and you'll see things like the IAD and so on. Okay, so I want to take us to Dataverse. And what I will be covering, I deleted all my bookmarks before. No, I hid my bookmarks before this presentation, so I actually have to type it in. So Dataverse as a platform has been developed in Harvard a few years ago. I think about 4 or 5 years ago now, and we have been running Dataverse since the beginning. Dataverse is a platform to manage data. It can be licensed data, which most of our data sets are, or research data, or any data, in fact. We are running Dataverse not only for UBC, but also for our colleagues in SFU, UNBC, and UBIC. For UBIC and UNBC, we also have their research data in. For SFU, they have their own research data repository called Radar. So we only have their licensed data sets. So we are a very large repository in UBC. We have, I think, second after Harvard. We have almost 31,000 data files. And we'll be showing you why we are doing this kind of work. So I will just grab a data file. I'll just take this one, Vancouver all-stream data file. So everything in Dataverse is data, right? Think about it, just pure data. And if you like to make sense of data, it has to be described. So you have in Dataverse, automatically you have a nice data citation. That's important because you want your stuff to be cited well. So it has a data citation with a persistent URL, handle URL identified, and that citation can go straight away into a publication. Metadata is quite robust. It allows you to describe your data set in multiple metadata standards, but mostly PDI. Let's go to versions. So as you can see in this specific data set by my colleague Paul Lissac, it has multiple versions for this file. And the Dataverse allows you to compare between the versions. What's the difference between version numbers 2 and 4? We can see how those data sets differ. And we can see a license has been added. Some files have been added. What's the file's difference and description of the files and so on. It allows us to see the difference between the versions for the files, which is really good because we can refer back to any versions as we need to. Other versions are archived on the last one released, but we can always change it as we go. Licenses are important. Licenses are important because it's up to you how you want to manage your data. You can license your data sets in many, many different ways. In UBC, we recommend you license your data in Creative Commons 0 license, which means anybody can reuse this data in any way. But we have multiple licenses for people to choose from, and the next data set I will show you has a different license, all Creative Commons. except some data sets which have custom license. But licenses are important because they allow people to use your data sets and also for you to be able to tell them how you want data sets to be used. So when you write your licenses, I recommend you to work with your legal team. You work with UBC legal team to write out 3 licenses. 3 licenses are terms of use. 1, data upload license and data usage license. So when you upload data, there's a license. When you download data, there's a license. Okay, I just want to go to one specific data set and show you what it can do for you. So search for Boston. And we'll take the first data set. It's data set from late 19th century about birth weight in Boston. So you see it has a nice citation yet again. There's a few versions for this data set. It tells you who created this data set, when it was created. It gives you the license for this data set. The license is custom license. This is Creative Commons, created by and share alike. Again, we can accommodate multiple licenses. It has 5 files. It has a very nice data dictionary. You need data dictionary in order to understand the data. So it has data manual, PDF, or Word document. And once you download this data set, you have a license, of course, too. So this is a data dictionary that explains what each variable is. Might be overkill for most data sets. Even a README file will work fine. But if you have a data dictionary, that's amazing. It's really good for people to reuse your data. What I wanted to show you, I wanted to show you a few things. First, I wanted to show you Dataverse as a software. With Dataverse, you are able to analyze your data within a browser. So you don't have to use SPSS or STAT or R. You can, of course, download it into a specific format and then use a STAT or R or SPSS to analyze your data. But if you don't have any of those packages and you want to do something simple on the fly, we allow you to do it with Dataverse. So if I go to the data set itself and I want to do some stats analysis, for instance, I want to do cross tabulation, just basic cross tab between birth year and the infant sex. I want to see how many boys and girls are born each year. I don't have to use any statistical packages. I just can run this quick model in Dataverse itself because Dataverse is built on R. And behind the scenes, it's running on R, so I can use analysis quite easily. So I can see in 1872, there were 48.3% girls and 51.7% boys. Now, what's interesting about Dataverse is it focuses on science reproducibility. So not only you have a citation for the data set itself, you also have a citation for the analysis you have done. And what's in this citation is something we call universal numeric fingerprint. That is a point for us, it's a signature for us that if you have used this specific data set and you run this specific analysis on this data set, your UNF, universal numeric fingerprint, should be the same. Which means if it's not the same, you've played with either with your analysis or you've played with your data, you change things. So it allows us to keep our research more reproducible. Universal numeric fingerprint is built into the Dataverse and allows us to do that. Okay, go back. Analysis. Okay, I'm going to talk about granular control. So for many of you who work with this data, you want to be able to control access to your data sets. Oops, go back. So Dataverse allows you to control access in multiple ways. For us, for instance, we can allow data sets to be open to a specific group of people, so not everybody will see it. We allow the data to be open to a specific institution like UBC or SFU or UNBC. Or we allow the data to be open to anybody. So it allows full control on those data sets, not only data studies, which is how data sets are packaged, but also file by file. I'll go to my own account quickly just to show you how it works. Licenses, of course. Go to one of my data sets, like this one. McGill and Dahl and UFC. And what I can do under permissions, I can define how this data set is to be accessed. I can define it by the study. The study itself can be public or not, or restricted. But also each file I can have control on each file, which means, again, if you have sensitive data sets, if you work in health sciences, and the journal asks you to open your data set, what you can do, and you have done it here in UBC in the past, you can open a data dictionary and the metadata about that data set for anybody to use, and we'll talk about discoverability in a second. And then after people can find your data set, because if you don't open it, nobody will ever find it, you can lock the file itself. You can say, hey, this file is going to be restricted now, locked. And you will only be able to download that file after you ask the researcher. So the data itself will be protected, and it will be only available after permission has been assigned by the researcher or copyright holder. So granular access to data is really interesting and important. Now let's talk about discovery, because it's important thing for us as well. If you put your data, if you ask by a journal to open your data and you put it on the server somewhere and give them a link, it doesn't help anybody, because people, first of all, will not be able to find the data set. Putting a data set in a system like Dataverse allows you to make your stuff findable and discoverable. What we do behind the scenes, we work with open access protocols, and we take those data sets or anything we get, and we make them findable in multiple places. We make them findable in Google. Again, you don't have to do anything. We do it for you behind the scenes. We make it findable in Google, in PubMed, in DataSite, in ORCID, in all those many places. So if you, let's actually just grab this title for a sec and go to any of our partners that work with DOIs, DataSite search. And somebody is searching for any data sets about specific topic, and they will be able to type the author's name or name of the data file or whatever they know about data file, focus about data file, keywords, and they will be able to find that data set in a second. I'm on wireless, so it's a little bit slow today. So people can find your data sets in multiple places only because we make it discoverable with DOIs. So DOIs allow us to make those data sets findable and reusable in many, many different places, including ORCID. I don't know how much you know about ORCID, but it's important identification for researchers. DataSite, DataOne, Google, Summon, and many other places. So if you're a librarian and you work in libraries, you can make those specific data sets exposable and findable behind the scenes in your Summon, for instance, which is discovery interface for libraries. Or I'm searching by title, but I can as easy search by last name. So those data sets quickly show up in many different places because we really know discovery and we know how to make those data sets findable. By findable, they can be reusable. By reusable, they can be citable. So this is a data set. Again, what we want to do, we want people to be able to find the data sets, and they can easily do that by using a established repository like Dataverse. Now, talking about Dataverse, we have 3 Dataverses in Canada right now. We run UBC one mostly for British Columbia. Our colleagues in Scholars Portal and University of Toronto, they're running a Dataverse for all Ontario institutions, 21 institutions. And we have colleagues in University of Alberta running Dataverse as well. So we're trying to cover the whole country. I know that a few more schools are installing Dataverse, like Dal and Manitoba, and we want to create a network of expertise in Canada for Dataverses as well. Also, we also work on national projects with Compute Canada to establish a federated research data repository where all research data sets will be findable. And we already made sure that all Dataverse data sets will be findable and exposable in a federated project as well. So you're working with Dataverse actually makes sense. It's here to stay for the next little while. Okay, and that's more or less what I wanted to cover. So it gives us lots of time for questions. So I'll go back to video, and maybe you guys, if you are on the app itself, you can just ask a question. If you are not on the app, Jana, can you remind people how to send a question to us?
Yes, for those on the web stream, you will need to email your question to info@westgrid.ca. That's info@westgrid.ca. So if anyone here in the video conference has any questions, please unmute yourself, and that's you can do that by clicking on the microphone button, and feel free to ask the question.
That's good. We might be able to save some time then. Jana, do you have any questions coming in email?
No, at the moment we don't have any via email.
So the presentation will be recorded and shared as well. The slides will be shared with you within, I think, next week.
Yeah, it'll take 1 to 2 days to post that, and then we will send the link around to everyone. There is a question. We have a question from Keith Jeffrey. He's typed it in the group chat. And so I don't know if you can see that, Eugene, but I'll read it out for you. The question is, are submissions approved before they become available?
That's a great question, Keith. And here the difference is between data management and data curation. We haven't talked about it at all, but we can quickly mention the difference between data management and data curation is by data curation allows you to work with the entire life cycle of data. So somebody in your institution will be curating those data sets, looking at them, looking that they are well described. If they're not well described, helping the researchers to describe those data sets. We don't do it in UBC. We don't have the right resources. I don't know anybody in Canada has resources to do it. We do data management, which means we help researchers to work with their data, but we don't curate it. We don't police it. Once the data is uploaded, one of us, either Paul, Isaac, or myself, will look at the data set, and we'll see that it has decent metadata, but we cannot commit to helping those researchers to make their data even better. But yes, to short answer, yes, we are looking at those data sets before they're being released to the public.
Eugene, I have a question from Dal.
Hi, Ari.
Oh, hi. So when someone signs up for to upload their data, they meet with one of the research data management team, and then are they granted, say, administrator access and kind of trained in Dataverse, or do you allow them to just create an account and upload data, or is it more of a managed process?
So again, there are quite a few ways to do it. What we do in UBC, we have a very small team for now. We are trying actually to establish Dataverse as an institutional service, but right now it's not. It's a library service. So what we do, we train people, we meet with them. Give them a 40 minutes an hour overview. We give them an account. We give them access to a Dataverse, and then they run with it by themselves.
Okay.
So not test Dataverses, they do it live. And Paul and I will look at it and see if it's a good enough data set, and then we'll release it to the public.
Okay. Thanks.
And Eugene, we have received some questions that have come in via email, the info@westgrid.email. So I've typed them into the group chat there. The first one is from Vanessa. How does the program compare to NCBI?
Can you say it again? I don't see the group chat somehow. If you don't mind, I couldn't hear it well.
Yeah, no problem. So this question comes from Vanessa. Her question is, how does the program compare to NCBI?
NCBI? That's a good question. So NCBI is run by NIH, National Institute of Health and States, and they usually work with big data sets. So Dataverse is not big data set software. You can handle whatever your browser can handle, which means you can handle up to 2 gigs of data in your browser, and your browsers are not happy after that. If you want a bigger data set, a big genomics data set, and they can be already in terabytes, that's not the right software. So the focus for Dataverse is on a small data, so on the long tail of data. For the big data, systems like NCBI or genomics or lots of them, they are more suited for that specific discipline, Vanessa. And Dataverse is really, we are focusing on the long tail of research data on our campuses.
Okay, I have another question. This one is from Vincent, and he asks, is there any concern that the same data set at different Dataverses is receiving a DOI from each?
Excellent question. Thanks, Vincent. DOIs, we didn't touch on them yet, but Vincent might know that we assign DOIs only to open data sets, open research data sets in UBC. We don't assign DOIs to licensed data sets. So if you have a data set in Dataverse coming from Stats Canada or from Health Canada, we do not assign a DOI to it. We would love Stats Canada, Health Canada to be on the ball already, start assigning DOIs, so we don't have to do it, but they're not. So we need to talk to them even more, and people like Vincent can help us to reach to them. So right now, in UBC, only open data sets are getting DOIs.
Okay. Another question from Margaret. Can you please go over your example with the birth rates in Boston in advanced statistical analysis?
Go over it again? Sure.
Yeah.
Maybe, do you have more questions? Because I don't want to bore other people, and we can do it.
Yeah, let's save that one then. We'll go back to that one. And the next question is from Karen. How difficult is it to remove a data set from Dataverse? And her reason for asking is because some organizations have data collection policies, policies around retention and disposition, et cetera, and they need to track and weed and dispose some of those data sets.
Yeah, excellent question. It's relatively easy to remove a data set from Dataverse. I will go to my account. It's a one-button operation. When I go to a specific data set, there's a way to deaccession it. So I can remove that data set. Now, the only thing that is interesting, if this data set has received the DOI, DOIs are not deletable. So you cannot delete a DOI. You can edit it, but you cannot delete it. So if you want to remove that specific data set, you will have to work with your DOI layer, which, again, in UBC, we have developed our own layer for DOIs because we are really massive DOI issuer. We have 200,000 DOIs issued. We'll work on it to redirect it to the 404 page or some kind of page that says that DOI has been deaccessioned. Other than that, by removing data set, it's gone.
Okay. Another question from Guru. Any comments on sensitive data, such as personal health information or aggregate data sets involving sensitive topics?
That's really the big challenge. Yeah. So what we do in UBC, we are working we actually created a holistic team of people to work with the advanced research computing. You may know as we call ourselves ARC, UBC ARC. And it's a team of people who does all things advanced research computing, including big data. I will quickly share it with you. On that team, we have myself, but we also have a whole bunch of other people. We have the Westgrid people, we have a system analysis, we have health sciences analysts, digital humanities analysts. But we also have Caitlin, who's our focus. Her focus is data privacy and security. So Caitlin and I work very closely for all things relating to sensitive data. So Caitlin and I will look at those questions, we'll try to analyze them, we'll see if they're appropriate to Dataverse, we'll see if this data set needs a data access committee and what kind of committee will need to look at this data set and all. So it makes sense to have a comprehensive, holistic team on campus that looks at all things data. So we have that in UBC, and we work collaboratively with other colleagues. Now, we do have health sciences data sets. I'll show you a quick example. For one, we have the health InfoWays data coming from UBIC, actually, our colleagues in UBIC. And this is an example of a data set. It's very recent, by the way, just months old. A survey of Canadian nurses. So for that specific data set, we had to develop our own custom license. And but data set is itself open and free to use. It's just the license is custom. So it's possible to work with sensitive data in Dataverse, but it will require you to consult with your colleagues who actually understand what you're doing.
And so a second part of that question, and maybe this is already covered in what you've said, but does that apply also to research data sets involving genomics data, such as whole genome and exome?
Again, excellent question. Now, I'm not an expert in this area, but going back to ARC, we have my colleague Jamie Rosner, who is our expert in genomics and biomedical sciences. So anytime we start dealing with biology or genomics data sets, I always involve Jamie as our go-to person for life sciences analysis. So it's a great idea to have a comprehensive group of people who you can rely on when you talk about data.
Great. Another question, and sorry, actually, maybe I'll just take a quick break. Does anyone in the video group here want to jump in and ask a question? Okay, I'll continue on. We've got two more from email. This next question is from Caroline. She asks, could you show us how articles are linked to data sets for those researchers who submit an article to an institution repository and want their data sets published at the same time?
Great question. Here we go. I'll give you one example. I just want to ensure that it's the right spelling. I'm looking for the one data set I know has been published. I know. Let me just find this data set and we'll see if it's the right one. No, I'm looking for an article about housing for pregnant cows. We have different kinds of research there in the Dataverse, and they're all good research. Just give me a quick second. I will show you how it's linked. I have to just to dig quickly. So it's not a perfect match, that's for sure. But Dataverse and our Dataverse, now institutional repository running DSpace, are connected by DOI. So we give a DOI. Let me just find this one, Crescent Beach. Okay, I know how to find it. Sorry, one sec. That's the thing. If you have a repository, you have to remember some specific data sets. Here we go. Effects of social housing in dairy cows. So this is a data set that is linked to a publication +1. So what we have, we have a citation to a +1 article. And in +1 article, when you go to the specific UIs, I'll just do that. The citation will take you back to the data set. That's the article in +1. And in article +1, under somewhere data, so it'll take you back to our Dataverse. Data availability. It takes you back to our Dataverse. So this is how we try to link between publications and data sets. Unfortunately, right now, this work is mostly manual. It will be easily expedited once we adopt OrcID into our workflows.
Okay, we don't have any other questions at the moment through the email, the info@westgrid.ca, so we can give another minute or two for some of those to come in. If you want, now could be a time to go back to Margaret's question about doing a review on your birth rates in Boston in advanced statistical.
Yeah, so I'm going to find this data set again. So what Dataverse allows you to do, it allows you to analyze your data in the browser. I'm going to get to that data again. And it's free data set, so Margaret can experiment with it right now herself. It's tabular data. And what I'm going to do, I'm just taking a couple of variables. For instance, I can take the mother's age and infant sex as an example, and try to tabulate them into a table as a cross-tab analysis. But there are many other analyses. You can do regressions. You can do logistic regression and a whole bunch of other things. I just do cross-tab because it's easy to understand. So I take mother's age and the child's sex, and I run a model that allows me to cross-tabulate them into one table. Oh, that's actually better not to know. This data. So that's mother's age and the child's sex. It allows us to see how many mothers were coming by specific age. What I'm trying to say, Dataverse is a decent platform to run analysis online, and what it does, it gives you not only the data set we can download as a zip file, but also UNF, Universal Numeric Fingerprint, and a citation to the data set, which you can include in your publication straight away. I don't know if Margaret wants to see something else, but if she wants, you can contact me offline. That's not my phone, by the way. John, anything else?
I don't see anything else at the moment. If anyone else in the video conference has any questions, please feel free to unmute and ask. Otherwise, I think that might be it on the email side.
Okay. Thanks you guys for sharing an hour and 15 minutes. I really appreciate it. If you have any further questions, happy to answer them offline.